Okay, today is June 7th. June 7th, 2011. This is Chapter 1 test. Don't worry about the state. Sometimes I forgot to take those off. Okay? We're going to be taking up the answers to this. Now, the very first question, if you notice, it's actually not drawn in here. But I recall, here's our 0. It's missing lines. We have 1, 2, 3, -1, -2, -3, -4, 1, 2, 3, 4, and -1, -3, and -4. Okay. Now, in this question, there were 4 points plotted. -3, -4 was one of them. And 1 was another. 1 was another. And 3, 4 was another. So, like I said, in this question, there were 4 points that were plotted. And the question asks us for the domain of the function. The domain refers to which axis? The x-axis. So, even though the very first question gives us the actual coordinates of every point, first coordinate, second, third, and fourth are all right here. That is not just the domain. The domain is just the x value. So our x values are -3, -1, 1, and +3. So we're looking for C. The domain has had 4 of the points. So if I were to write this as a domain, we had domain equal to -3, -1, 1, and 3. That is the domain of this function. There's no line connecting those points, so the domain doesn't represent every real number. It's just those 4 major points. Okay. Question 2. Identify which transformation would be performed in f at x is equal to -3 times x minus 4 squared plus 5. So, what's important here is we have our a value, which is -3, our h value, -4, and our k value, which is +5. If you guys remember our function was f at x is equal to a times x minus h squared plus k. A dealt with movement, or A dealt with stretching a parabola. H dealt with movements on the x and y axis, and K was on the y axis, H was on the x axis. So we have to figure out which of these is a logical answer. First one says narrowed by a factor of 5. So they're discussing an A value. Is our A a 5? No. So A cannot be an answer. Horizontal translation to the right by 4. Is that possible? It says -4. Why is it possible? That's right. So when we have the brackets, if h is negative, that means we're going in the positive direction. The positive direction is to the right. So this is an option, but whenever you do multiple choice, make sure you go through all of them and eliminate the other one. Horizontal translation to the left by 4. No, that's not correct. Vertical translation down by 3. No, our translation is up by 5. So our answer is B for the second one. Questions? Concerns? Okay. Use differences to determine if the following table of values is linear, quadratic, neither, or both. So when we're doing that, we're essentially looking for our differences in our y-axis or our f at x. It's important, though, to check first that your x factors are going up by the same amount. So this one goes up by 1, 1, 1, 1. Good. Okay, so our x's are consistent. So now we're going to check the differences in our y's. Our first difference, we went up by 6. Next one, we went up by 9, 12, and 15. To be linear, our first differences have to be all the same. Are all of our first differences the same? Okay, so we know it's not linear. And we know it's not both because linear is no longer an option. So we've gotten rid of 2 of them. There's only 2 answers left. To be quadratic, we have to check for the second differences. So we find the differences of the first differences. 3, 3, and 3. From 6 to 9 is 3. From 9 to 12 is 3. 12 to 15 is 3. Are all the second differences the same? That means we have a quadratic function. Do you guys have any questions about that one? Okay. 4. A function is a relation in which for each y value there is more than one x value. True or false? So what the first one says is for each of our y values, we have a 4. So let's say we have 1, 2, 3. There are more than one x value. So we have an x value of 1. Sorry, negative 4, let's say, negative 3, negative 1. Can this be a function? Oh, I don't remember. This could be a function because we don't have 2 y values for one x value. Remember, if we do our vertical line test, it's going to hit this every time only once. So it passes the vertical line test, so A could be an answer. Let's see what B says. A relation in which for each y value there is only one x value. So they're saying there's only one x value. So if I had a 4, I couldn't have, I couldn't have this and this. They're saying that if y is 4 and x is negative 1, I can't have negative 3 and 4. Is that true? No, that's not true. I could have negative 3 and 4. So this is false. C, a relation in which for each x value there is more than one y value. We know that's false because what that means, if I have an x value of 3 and I have 3 different y values, my vertical line test doesn't pass. So we know C is false. And a relation in which for each x value there is only one y value. For each x value there is only one y value. So if I have negative 5, there's only one y value. That one's definitely true. So let's go back to the first one and figure out why it would be false. A relation for which each y value there is more than one x value. Is that what it says? Oh, for each y value. Even I trick myself. For each y value, okay. So because it says for each, that doesn't mean there has to be one for every single one. D is our answer. There's only one value for each x value. So we can pass our vertical line test. That one was tricky. Okay. Question 5. In the table of values above, f at 3. Which of these represents f at 3? This 3 refers to which? The first question, second pair, third pair, or the fourth pair? Why the second one? Okay. Stuart, do you know? Sorry, x value. So this question says function f at x. Now they haven't given us an equation, but they've given us the values. When x is 1, well, when we were to write that as a question, that would be f at 1. When x is 3, that would be f at 3. We're replacing the x value with 3. So they asked us for f at 3. Our fourth option was f at 5, and our fifth was f at 7. So first option, third, and fourth are no good. We're looking for f at 3. which is this one here. And they want to know what the value is f at 3. So f at x would be equal to 4 when we're at f at 3. In other words, we're looking for A. Okay, question 6. In this question on your test, I've drawn the diagrams. I personally don't remember which ones I drew them under, so we're just going to redraw them quickly. Okay? So the very first one, graph of f at x is equal to x plus 3 squared minus 4. We always start at the origin, and there's been no stretch factor. So it says h is positive 3, so that means you move in a negative direction, 1, 2, 3. And k is negative 4, so we move down 4, 1, 2, 3, 4. Our new vertex is here. We were to go over 1, up 1, over 2, up 4. We have a parabola that looks roughly like this. Now, like I said, I don't remember where I drew these in yours, but we're just going to do them in order. So this one represents number 6. Number 7. Same idea. Only difference is h is negative 3. If h is negative 3, that means we move in the positive direction 3. And k is negative 4, so we still are down 4. Over 1, up 1. So the difference between number 6 and number 7 is that they just have horizontal opposites. This one moves 3 to the left. This one moves 3 to the right. Question 8. Which of these graphs? Okay, this one has a stretch. Once again, we move to the right 3 because it's negative 3, 1, 2, 3. And our k is positive 4. So our vertex starts up here. But it says as an A factor of negative 2. So instead of facing upwards, this is going to face downwards. And instead of going over 1, up 1, we go over 1, down 2. Over 1, down 2. When we go 2, instead of going down 4, we go down 8 because we multiply by that 2. So 1, 2, 3, 4, 5, 6, 7, 8. So if we take a look at this, this parabola is thinner than the other ones we've drawn. Plus, it's facing downwards. Number 9. This one is pretty straightforward. We're at the origin. It's facing downwards, but it's stretched. So, a way to compare this to the last one, we'll do number 10 here, is we'll draw our normal one. And since we're trying to get a feel for it, let's say our parabola looked like this. The only difference I would have had to notice between number 10 and number 9 is that number 9 would be drawn thinner than number 10 would because it's in a factor of 2. It's been stretched by a factor of 2. Okay, question 11. If f at x is x squared minus 2x minus 10, determine f at 2. So what they're asking us is to replace all of the x's in this equation with the value of 2. So you would have wrote it to look like this. F at 2 is equal to 2 squared minus 2 times 2 minus 10. That would give us 4 minus 4 minus 10. 4 subtract 4 is 0. Subtract 10 is negative 10. Same question. This time we replace the x's with negative 2. Negative 2 squared minus 2 times negative 2 minus 10. Negative 2 squared is again positive 4. Negative 2 times negative 2 is positive 4. Subtract 10. 4 plus 4 is 8. Subtract 10 is negative 2. So we have two different answers. Negative 10 for the first one, negative 2 for the second one. State the domain and range of each of the following functions. The first function is our normal parabola. If we were to draw it, remember our vertex is on the origin, and it's heading upwards. Our domain deals with the x-axis, and since there's no limitations, our domain in this one is x is a set of all real numbers. X is every real number. Our range, though, has a limitation. Our range is y is a set of all real numbers such that, if we look at this parabola, it only heads one direction. Which way is it going? Up. So that means it is greater than what at all times? 0. We're on the origin. So such that y is greater than and equal to 0 in our range for the first one. In our second one, our vertex is moved. The stretch doesn't actually affect it. It'll still go side to side forever. It's our vertex that has changed. Once again, our left and right two, our horizontal shift, really won't affect our domain either. And finally, our vertical shift doesn't affect our domain. So our domain is going to stay the same. X is a set of all real numbers. But our range changes. The one thing that affects our range is our k value of positive 4. Because our vertex is now 4 up from where it was before, if we were to draw it, we have a vertex over here. If you notice, our range is always above positive 4. So again, y is all real numbers such that y is greater than and equal to positive 4. Graph the following parabola showing all steps. Okay. For some reason this didn't come out very nice, but we're going to draw our scales here. This is our origin. 1, 2, 3, 4, 5, 6, 7, 8. Negative 1, negative 2, negative 3, negative 4. Ooh. The scale is terrible. 1, 2, 3, 4, 5, 6. And negative 1. Okay. So if we take a look at this, our vertex hasn't shifted at all. There's no h and there's no k. So the vertex of this parabola is going to be right at the origin. The only things that have changed is our a. Our a is negative a half. So first of all, that means our parabola is going to be facing downwards because it's negative. And secondly, it's going to be compressed. So remember that we normally go over 1 and down 1 if it's facing downwards. Instead of going down 1, we multiply 1 by a half. So I would go over 1, down a half. Over 1, down a half. Same idea as with 2. Normally we go over 2, down 4 because we square 2. I'd have to take 4 and multiply by a half. 4 by a half is 2, so I go over 2, down 2. Over 2, down 2. And same idea with 3. 3 we normally go over 3. 3 squared is 9. So we go down 9, but we need to multiply that 9 by a half. So we go down 4.5. Over 3, down 4.5. This parabola is compressed compared to our normal one. Our second parabola, the origin has been moved. The a factors are the exact same. Our h is positive 4, so we go over to the left 4. 1, 2, 3, 4. And our k factor is negative 3, so we go down 3. 1, 2, 3. Our new vertex is here. We go over 1, up 1. Over 2, up 4. Over 3, up 9. Okay, question 14 says to write an equation of the given function after the following transformations. Show how you got your equation. So essentially, it says to start at the origin So we start at the origin. We have f at x equals x squared. And it says it narrows by a factor of 3, turns down, translated horizontally 6 units, and vertically 2 units down. So let's talk about each of these. Narrows by a factor of 3. Which of the variables is that referring to? A, H, or K? A. Is A positive 3 or a third? You're right, it's going to be negative 3. It's going to be 3, but because it turns downward, A is going to be negative 3. So we know that A is going to be negative 3. It's translated horizontally 6 units to the right. What does that mean? H is going to be good. Negative 6. And finally, our K is going to be down 2 units. So negative 2 will be our K. So when we go to put this into an equation, our equation says f at x is equal to negative 3 x minus 6 squared minus 2. We're dealing with our A, which was negative 3, our H, which is negative 6, and our K is negative 2. Okay, 15 is the same type of question, but in this one they want you to say what the transformations are. So, same idea as above, you guys are supposed to write it in words instead. So our A is negative 3, so that means stretched by a factor of 3. And because it's negative, it turns downwards. Our H is negative 2, so vertex, is it IX? We'll just say shifted 2 units right. And finally, our K is negative 4, so it is shifted 2 units down. Yeah, it turns downwards. That was the second one we wrote. How much is... Okay, question 15b. It's the exact same idea as the one before. Our A is positive, so we know it's going to open upwards. It's also 1/3. So instead of being stretched, it's going to be compressed by a factor of a third. Our H is positive 3, so it is shifted 3 units left. And finally, our K is positive 5, so it is shifted 5 units up. Okay, question 16. Very few people actually got on this test. What I needed you guys to do is I needed you to solve the table, then graph the function. So, this is what it was asking. If f at x is equal to the square root of x, when f at x is 0, what is our square root of 0? 0. So, f at x is 0. So let's say we have our function. Here's our origin, 0 and 0. 1, 2, 3, 4, 5, 6, 7. 1, 2, 5, 6, 7, 8, 9, 10, 11, 12. Oh, wow. 15. We have our numbers across the bottom. When x is 0, y is also 0. So this is our first point right at the origin. Our second one, we're looking for f at 1, which means they want the square root of 1. What's the square root of 1? 1. Again, so when f is 1, sorry, when x is 1, f is 1. Now, technically, I don't know if any of you guys got the full answer of this, but the square root of 1 is not just 1. Anyone remember from our quadratic formula what it's going to be? I know that 1 squared equals 1. What does negative 1 squared equal? What's negative 1 times negative 1? So, the answer to this is actually plus or minus 1. There are two answers to that. So, when x is 1, y is positive 1 and negative 1. There are two answers to that. The same idea as with 4. Square root of 4 is plus or minus 2. So when x was 4, we have positive 2 as an answer, and we have negative 2 as an answer. And finally, with our 9, square root of 9 is plus or minus 3. So when we're at 9, we have the answer of positive 3, and, well, negative 3 would be down here. So if you guys notice, this is a sideways what? Parabola, that's right. But is this a function? No, it doesn't pass the vertical line test. But it is a sideways parabola. Can you have negative x values for this equation? No, we can't. Why not? We cannot have negative x values because I cannot find the square root of a negative. Square root of negative 3, error in your calculator if you were to type it in. There are no two numbers that multiply to make a negative. So you would say can't square root a negative number. What is the domain and range of this function? I'm going to go with the easier one first. Because it's a sideways parabola, instead of the domain being every real number, what's going to happen is the range will be y is a set of all real numbers. And what that means is these arrows will go forever upwards and forever downwards. They'll never stop. I'm positive. Now, our domain is what's different. Normally our domain is every real number, but in this case, if you notice, our domain only goes up to 0. So x is every real number such that x is greater than and equal to 0. It's a little different from our parabolas, if you guys remember from the earlier page. All right, gentlemen, question 17. A stone is dropped from a bridge into a river. The height of the stone above the water after it has been released is modeled by the function h at t equals 80 minus 5t squared, where h at t is the height and t is time. Now, at this point, you guys didn't actually know how to find x intercepts, find y intercepts, find much of these equations. But since we've done the entire course, instead of making an xy table, which is what you guys would have done on this, to solve, you would have had t and h at t, and you guys would have made a table for values of t at 0, 1, 2, 3. And you would have solved for it by plugging in those values. This is supposed to be a t. Into the t in this equation. A faster way to do this, because we now know how high is the bridge, we can put this into vertex form to figure out how high the bridge is. Since this person is dropping it from a bridge, we know that there is no time before 0. Time has to start at 0. So I'm going to plug in x at 0 for the very first one. So h at 0, this is when they're standing holding the rock on the bridge, is 80 subtract t squared. 0 squared is 0 times 5 is 0. The height of the bridge is 0. How long does it take for the stone to hit the water? Again, we can plug in values, h at 1, h at 2, h at 3. Or, since you guys have done this whole course, you know that they're talking about the X intercept there. So, if we were supposed to graph this function, we say this is roughly around 80, 10, 20, 30, 40, 50, 60, 70, 80. We start at 0. If I factor this, h at t, I can find my X intercept. So 80 minus 5t squared. I could take a common factor of 5 out. That's going to give me 16 minus t squared. If you guys notice, this is a what? Anyone remember factoring? Special case? Oh, not quite. Did someone say it? Matthew, what is it? It wasn't Paul who said it, though. Someone is saying it. Oh, it's a perfect square. Good, it is a perfect square. Okay? So what that means is that can be factored. We have 4 at t, 4 at t, and we have a plus and a minus. We found the square root of the first term and the last term. We're going to set these two brackets equal to 0 because we're trying to find the x-intercept, and the x-intercept is when the y value is equal to 0. So, 4 plus t equals 0, 4 minus t equals 0. And we're going to solve for t. In this case, t is negative 4, and in this one, t is positive 4. Now we know that we don't have the rock before 0, because that's when he drops it. Time can't be before 0, so this is illogical. So we know at 4, 1, 2, 3, that's not a 3, 3, 4, that's when the rock's going to hit the ground. We know at 4 seconds. We can figure that out by factoring, so at 4 seconds. And finally, the domain and range. Now, you need to make sense of this. Because you cannot drop a rock before 0, we can't go back in time, our domain's going to start after 0. So our domain is x is every real number such that x is greater than and equal to 0. And our range, y is a set of every real number. Is there any limitations on y? What is it? 80, that's right. Such that y is less than and equal to 80. If we look at our graph, starts at 80, hits the water after 4 seconds, heading downwards. This is a rough estimate of our graph. So we were able to solve that question by factoring, knowledge we didn't have at that time. Okay, it was just asked if there's any other limits for x. Now, like I said, technically there is no limits for x. The real domain of this function was x is every real numbers. But because we said we can't go back in time, you can't drop a rock before we start, 0 was our limitation. And you could say that, is it water or the ground it's hitting? Water. Let's say the water is pretty much at 4. You could say that it also stops at 4. If you had said that in your answer, so let's say option 2, because you're trying to make logical sense of this, if you had said the domain is every real number such that x is greater than equal to 0 and less than and equal to 4, I would have accepted an answer like that too, because you said that the rock was moving through the air between the times of 0 and 4. Both of those would have been acceptable if you're able to make logical sense of that. Homework. You guys are going to do chapter self-test for chapter 1. It's on page 70. It's one page, a couple questions. 1 page of homework. Please do it. Come back with questions if you have any tomorrow.